Guys, can you start working on question 8, please? Question 8. The sheet. I'll give you about 5 minutes or so. Good morning. Good morning, sir. Guys, try question 8, please. Question 8. All right. If you haven't done it, I know some of you have done question 8. So, but if you haven't done it, let me show you how to do it. So the question 8 tells you that you have you have a random sample from a population with mean equal to 0 and the variance sigma squared, right? And the question is to find k so that this is an unbiased estimator for sigma squared. Remember, an estimator is unbiased if the bias is 0, right? You remember that from the review session last week, okay? So you have this estimator, and we want to find k so that this estimator is unbiased for sigma squared. So what we need to do is to first find the bias, of this estimator, right? Okay, and remember the bias is defined as the definition of bias is simply the expectation of the estimator minus the parameter that you're trying to estimate, right? So this will be yeah. Now you should take the expectation inside. Because k is a constant, you can pull it outside and take the expectation inside. Like this, okay? Now the expectation of xi squared, I'm going to do a trick here. I'm going to write this as see what I have written expectation of xi squared as this minus this term plus this term. So I haven't changed anything, right? Now, let me ask you, what do you know about this? The expectation of xi squared minus the square of the expectation is equal to? Come on, guys, talk to me. This is equal to what? This is equal to the variance of xi. Hi, come on. And we are told that the variance of xi is sigma squared, right? And the expectation of xi is the mean of the population, which is, we are told that the mean, this is the mean, which is mu, and we are told that mu is equal to 0. Are you guys with me or not? Yeah. Yes? No? Okay, so what you have is that this is equal to k times the sum of sigma squared minus sigma squared. Now, sigma squared is I, so this is k times n sigma squared minus sigma squared. And this is equal to 0 if k is equal to 1 over n. Right? So what this implies is that the bias of the estimator is 0 if k is 1 over n. So in other words, an unbiased estimator of sigma squared. Okay, are you able to follow this, guys? Or no? Talk to me, guys. Are you okay with this? Any questions? You guys okay? Okay, good. All right, so that's the first part of question 8. The second part of question 8 is asking you, what is the sampling distribution of this estimator sigma squared hat, right? Now, to answer this question, you need to go back to the review session that we talked about last Friday. So the estimator that we have is, this is the estimator that we have. Okay, and we want distribution of this estimator. Now what I'm going to do, I'm going to multiply this by sigma squared, and I'm going to divide, because I have multiplied by sigma squared, we need to divide by the same quantity, right? So this is going to be sigma squared by n. All right. Now let me test your memory. Do you recall this? Have you seen this before? I mean, if you remember the stuff that we did last Friday, or not last Friday, I think the week before. Yeah, not the Friday last week, but the week before. Do you recall this? Do you see something about this? Yes. Yes. Exactly. Yeah. So if you look at it's actually property 6 of chi-squared. If you look at property number 6 of the distribution, which is in the course web page, right? There's also video on it as well as notes. You will see that because of that, this guy here has a chi-square distribution with n degree of freedom. So this is the answer. If you don't remember, guys, please go to the course website and look at property number 6 of the chi-square distribution, the notes on chi-squared. You will see that property, right? All right, so the sampling distribution of sigma hat squared is simply this constant multiplied by it should be n, guys, multiplied by a variable with n degree of freedom. Okay. All right. So that's question number. So can you a few minutes try and see if you can do question 9 by yourself. خلاص. Okay, guys, let's see how we can do question number 9. I know some of you have it. This is, you have a random sample from a uniform 0 theta, where theta is unknown, and it's similar to the previous one that we did. So you have x1 to xn, which are IID from a uniform distribution from 0 to theta. And you have this estimator, which is k times the sample mean, right? And once again, we want to find k so that this is the unbiased estimator for theta. So what you need to do is to find the bias, as in the previous question, find the bias, and then set it to 0, and then solve for k. The bias is defined as, this is the definition of bias, hope you remember. So this is the expectation of k times x bar minus. So you can pull it outside. X bar is the sample mean, so now n is a constant, so you can again take the n outside. Now I'm sure you know from stuff you have done before that if you have a uniform 0 theta, what's the expectation? Guys? Theta over 2, yes, exactly. So it's, yeah, so it's a plus, remember it's a plus b divided by 2. A is 0, b is theta. Right? So, okay, theta over 2 is a constant, so we have n theta over 2 minus theta. Right? Okay. Defined to be 2 times the sample mean is an unbiased So that's the first part of the question. The second part is to find the variance. Now to find the variance, so you want to find the variance of 2 times x bar, right? Now if you pull the 2 outside, it becomes 4 times the variance of x bar. And the variance of 1 over n times the sum of xi. Now if you pull the n outside, it becomes times the sum 1 to n of variance of xi. Now once again, I hope you remember the formula for the variance of a uniform, which is b minus a squared divided by 12. So in this case, it will be theta minus 0 squared divided by 12, which is, will be theta squared divided by 12, right? Now this is a constant with respect to I, so this will be 4 divided by n squared multiplied by n theta squared divided by 12, right? And if you simplify this, it will be theta squared divided by 3n. Okay. This approaches 0 as n approaches infinity. So what we can say is that this estimator, apart from being an unbiased estimator, is also a consistent estimator. So this implies that theta hat equal to 2 times x bar is consistent. Remember, an estimator is consistent if the MSC, the mean squared error, approaches 0. In this case, the MSC is the same as the variance because the bias is equal to 0. Right? Okay, so this estimator has both the good properties, that is, it's unbiased as well as consistent. Right? All right, guys, any questions, please? Are you all okay? You okay, sir? Yeah, okay. Can you do the next one, please? Question 10. This is question 10 here. you have to be a little careful. We have a random sample from a we have x1 to xn. Right, with m, right? You have to, this m is not n, okay? N is a sample size, m is the size parameter for the binomial, right? So there are two different things, okay? So we have this estimate p hat. The sample mean is with respect to n, right? Not m, right? Now the first thing is we want to find the bias. So the bias is this. So it's the expectation of this, yeah. Now n plus 2 is a constant, so you can put it outside. So it's 1 over n plus 2 times the expectation of x bar. Okay. Right, then you have 1 plus 2 right, guys? Now x bar is the sample mean with respect to n. So I'm going to write that down. So this is the expectation of 1 over n times the sum of xi plus 1 outside minus p. Right, now take the expectation inside the brackets, you get 1 over n okay. Now I'm sure all of you know that the expected value of a binomial with these parameters is m times p, right? So this is going to be are you with me, guys, so far or no? Are you guys okay? Now m times p is a constant with respect to I, so the sum of it all right, it's going to be n m times p. Yeah, the n here and the n here cancel out, so what you have is mp plus 1 divided by n plus 2 minus p. So this is the expression for the bias of p hat. Okay, are you guys okay with this or no? So you had to be a little careful about, because the sample mean is with respect to n, and m is the parameter of the binomial. So they're two different things. So you have to be a little careful when you take the expectation, right? Okay. Right. So that's part is to do the the variance. The variance of is this, yeah? Now n plus 2 is a constant, so you should pull it outside. It becomes this. Yeah? Remember, when you pull a constant outside the variance, you need to square it, right? Now the variance of x bar plus 1 is the same as the variance of x bar, because I hope you learned this in probability 1, that adding a constant or subtracting a constant does not change the variance. So the variance of x bar plus 1 is the same as the variance of x bar. Okay. Now, I just put the definition of x bar. Now, I'm going to pull the n outside of the brackets. So it's going to become n squared. All right, and I'm sure all of you know that the variance of a binomial is mp times 1 minus p. So this becomes the sum of mp multiplied by 1 minus p. Once again, this is a constant with respect to I, so this becomes the sum of a constant is n times the constant. Right, this n will cancel with one of the n's here. So the final answer for the variance is m p 1 minus p divided by all right, so this is the final formula for the variance of p hat. Right, and as n approaches infinity rather, this goes to 0 as n approaches infinity. That's a good thing. But however, at this one here, as n approaches infinity, this goes to minus p, so which is not a good thing. So what this means is that this is not an unbiased estimator. In other words, it is a biased estimator, and it's also not consistent, because remember, for an estimator to be consistent, the MSC must approach 0. In this case, MSC cannot approach 0, because remember, the MSC is the, if you recall from the stuff that we did a couple of weeks ago, you will remember that the MSC is the sum of these two quantities, right? We know that this guy here this approaches 0. We know that this approaches 0, but this guy here approaches minus p squared, right? So hence, the sum of them approaches p squared. Right? So what this means is that this estimator is not consistent and is not unbiased. So in both counts, it's not a good estimator. Right? Do you get that, guys, or not? So p hat is not, sorry, let me write it down. It's not unbiased and not consistent. Right? So it's not a good estimator at all. Right? Just an example. I mean, I'm sure there are ways to construct good estimators, but this is not a good example. Okay. Any questions, guys? Yes, sure. We have time. Do we have time left? How much? Huh? Okay. All right, guys. So the full solutions to these, all the 10 questions, I'm sorry I'm able to do only 3 of the questions, but you should go to the course website. You will see the typed solutions, the handwritten solution, and the video solutions for all the 10 questions in the tutorial sheet. Right? Okay, guys, have a good day, and I will see you later. Any questions, just feel free to contact me, okay, 24/7. Thank you, man.